Hello and welcome to FEM Expert. Today we will present you a medium tutorial in which we will show you how to analyze a beam T-junction modeled with beam type elements using Ansys APDL programming language. We will begin with the Ansys instance, and what we'll do is create the key points for the T-junction, for the beams of the T-junctions, and then continue the general procedure. So the first step is to do prep7 / prep7, which means going to preprocessor, and here we will create a key point number 1 on the origin, then key point number 2 at 0.5 on the Z axis, and key point number 3 at minus 0.5 on the Z axis. This way we'll have 3 key points here at minus 0.5 and plus 0.5, and key point 4 at 1 meter on the x-axis. Since we know all these key points, we're going to create lines between them. That can be done with the L command, comma, we have point 1 and point 2. So line between key points 1 and 2, line between key points 1 and 3, and line between key points 1 and 4. And so as we go to the ISO view, you'll see we have the 3 key points, the 4 key points, and if you do a G-plot, we have the lines and the key points of the T-junctions already defined. So this is key point 1, we have 2, 3, and 4. Okay, so now what we have to do is to define, in a general normal situation, we have to define element types, material properties, section, and other characteristics. So the first thing, element type 1 is type 188. Element type 188, you can check it on element type delete. Beam 188 has been defined. For the material, there's no real constants here, and we have to do the material properties. Material properties are MP material properties, density, the Laplace density, the material number 1, and the value 7,800 kilograms per cubic meter. Then we have MP, EX Young's modulus for material 1, 2.1811, and MP, PRXY, Poisson's coefficient for material 1, 0.3. You can verify this on material models, density 7,800, linear isotropic 2.111, 0.3. Great, at this point we have most of what we need. And what we'll have to do is now I have to define the sections. We're going to use for that the command line sec type. The section ID is 1, the type is beam, the subtype is hrec, and the name will be beam. We hit enter, and then we have to do sec data, and its value is 40 by 1000, 40 by 1000, 3 divided by 1000, 3 divided by 1000, 3 divided by 1000, and once more 3 divided by 1000. These are the width, height of the profile, and these are the thicknesses of profile per each wall. We do that, and we have the sec data assigned. Now what we have to do is to tell Ansys that these lines have these properties, that we're going to do it with the lines attributes, LATT, lines attributes. For all the lines that are selected, we have material 1, there's no real constant, type 1, and then we have 1, 2, 3, 4 commas, and section number 1. After we have done that, you can do a line list to see if the properties of the lines are correct. We have material 1, type 1, and section 1. We don't see it here, but it for sure has been properly assigned, because otherwise we would have obtained a message. Okay, what we have to do now is to mesh this line. So we're going to define the element size for the meshing as 0.025. And we're gonna do an L mesh, all order. we have it meshed, we have the elements meshed. Now we're going to do a displacement on key points. On key point 2, we're going to restrain all of this, we're going to restrain the displacement on key point 2 on all directions with the value 0. And you can see we just got it. If you go with the arrow down, you can go back to the last order and we can change that 2 to 3. We do it again, and now we have to apply the force at the free end of the junction. So for that, we're gonna do force on key point FK key point 4. We know that's for key point 4. Otherwise, you can use P and pick it. The lab is Fy, and the value is minus 100 newtons. So there we have it. Now what we have to do is go into the solution module, so /solu and solve. Solution is done. So to analyze the result, we have to general post-processing. So the /pos1 set last to read last results, and then we're gonna plot the summation of displacement. As you can see, we have the displacement, and if we try to plot the von Mises stress, which is PNL sol, S stress, equivalent EQV, we'll see that there's nothing is being shown. That's because for the stress we need to have the /e shape that 1 order and replot that view. That way we're gonna visualize the beam in a realistic way. So there we have the stress. We're gonna put the PL vectorial U. That's the vectorial displacement, and there you have it. A very easy way to simulate a T-junction utilizing a lot of APDL commands. So to exit, normally you would have hit quit. Another easy way is to do /exit. You have a series of other parameters you can introduce, but if you just want to exit very fast, Ansys, you can just do /exit, hit enter, and you're out of Ansys. So we hope you enjoyed this presentation, and we would like to thank you for your attention. For more tutorials, please visit us on our community and follow us on the social media.